Alright guys, today we're going to take a look at section 3.1, solving systems using tables and graphs. This shouldn't be really anything new as far as the graphing part. Looking at the table may be, but we're not going to do a ton of stuff with the table. It's just another option. So when they ask us to solve systems of equations, the first thing you need to know is what is a system of equations? Well, that's just a set of two or more equations. Okay. A linear system is where both of the equations are linear equations. That means they graph a line. And that's both or all, because you might have more than three. So both or all equations are linear. They graph lines. And then the solution of a system is a set of values that make all of the given equations true. And it is usually written as an ordered pair. So we're going to take a look at problem 1 down here. It says to solve by graphing, and they want to know what is the solution for that system. Well, the very first thing you've got to do is rewrite each equation in slope-intercept form. Okay, and I didn't leave myself a lot of room, so we're going to try to squeeze them in over here in the margin. So if I take this first equation, I'm going to have negative 3x plus 2y equals 8. Move the 3x over, so that gives me 2y equals a positive 3x plus 8. Divide everything by 2, and y equals 3 halves x plus 4. Now, I need to go ahead and graph that one. So I'm going to begin on the y-axis at 4 because that was my y-intercept. My slope is 3 over 2. So from my y-intercept, I'm going to go up 1, 2, 3, and over 2. I'd like to go again, but I'm running out of room. So what I'm going to do is come back to my y-intercept and go down 3 and left 2. And I'm just going to do that as many times as I have room for, because the more points I have on my graph, the more accurate my graph will be. So if you're going to solve these by graphing, you have to have graph paper. You have to use a ruler. You've got to be very careful and as accurate as possible. So now let's take this equation, get it in slope-intercept form. So move my x over, divide everything by 2, and then I will graph that one as well. This time my y-intercept is negative 4. From there, I'm going to go down 1 and right 2. Then I'm also going to come back here and go up 1 and left 2. And draw in my line. And what I'm looking for is the ordered pair where those two lines intersect. This ordered pair here is 1, 2, 3, -4, -2. So your solution is -4, -2. One way to check that is to plug in -4 for x and -2 for y. Make sure it makes that a true statement, and then plug in the -4 and the -2 in the other equation. It must make that equation true as well. So now, the next thing we're going to do is use our graphing calculator, and we're going to do the same system of equations. So I'm going to go ahead and rewrite down my equations after I've got them in slope-intercept form, because that's what we'll have to enter into the calculator. And we're going to take a look at what our table looks like when we enter both of those. So let's check my mode real quick. Okay, all of that looks good. So then y equals 3 over 2 x plus 4. Then I want to go down and use y equals -1/2 x minus 4. And I can press graph, and it should look like the graph that we did together. But when you look at the graph on the calculator, you don't have the grids to look at. So you can't really count left or right, up or down to see where they intersect at. So if you're planning on using the calculator, you've got to be able to look at the table. So here is my table, and I want to remind you what our answer was here. It was -4, -2. So what I want to do is go up to where x is -4, and I want you to take a look. When x is -4, both of the y values are -2. Okay? And so remember, what this means is that on the first line, a point that's on the line is -4, -2. On the second line, -4, -2 is also a point. So they share this point. That has to be where they intersect at. So if you're going to use a table, you have to figure out where your y values are the same in both columns. So looking here, your solution is -4, -2, because the y values are the same. Gives us the exact same answer we got when we did it by graphing over here. This is just another option. All right, so if the equations graph intersecting lines, here are just some general statements, some things that you need to know. Okay, if the equations graph intersecting lines, there is going to be one solution. Okay, and that solution is going to be written as an ordered pair. Now, if the equations happen to graph lines that are parallel, they are never going to intersect. They do not share any points. So there's no single ordered pair that will make both equations true. This is when there is no solution. Okay, and it's no solution because there are no common points. Now, if the equations happen to graph the same line, here's the thing. They are going to share each and every point. So there are infinitely many solutions. And we're going to take a look at some pictures of those in just a second here. That's on our next sheet. All right, so this is the part that may be just a little bit new. Okay? Before, when you worked with systems of equations, you always just found where they intersected and that was it. Well, in Algebra 2, we've got to talk about what type of system they are. Okay? So you've got three different types. You've got a consistent and dependent system. That's where both of the lines graph in the same place. They both end up graphing the same line. Okay? The consistent part means there is a solution. And the dependent part, that means there are infinitely many solutions. Okay, and I remember this one because since they graph the same line, one line depends on the other line for each and every point. Okay, so a dependent system has infinitely many solutions. Okay, and this is what they look like. Consistent and independent, well, this is where you have intersecting lines. There is only one solution. And again, the consistent part means there is a solution. The independent part means there is only one solution. Those two lines are independent of each other except for that one point. Okay. The next type of system is the one that is inconsistent. So remember, if consistent meant there was a solution, inconsistent means there's not going to be a system. Okay? This is when you have something where the lines never touch. That means they are parallel. And my picture for that somehow ended up on the next page. So let me slide this up a little bit and you can see it. There you go. So there's my parallel lines. There is no solution. If they ask what type of system it is, your answer would be inconsistent. So now, the very last thing we're going to do is figure out what type of system something is without graphing it. And we're not necessarily going to solve the system to do it. So what we're going to do, I've got it out, typed out for you here step by step. First, you're going to rewrite each equation in slope-intercept form. So if I take this equation, move the 2x over, and then when I divide everything by 4, your 2 over 4 will reduce to 1/2 x. 6 over 4 will reduce to 3/2. For the other one, my 8y equals 4x minus 12. All I have to do is divide both sides by 8. So y equals 4 over 8 is 1/2 x. Negative 12 over 8 is going to give me, divide both of those by 4, gives me negative 3 over 2. And so next we got 3 questions we've got to answer now that we've done that. Are they the same equation? Well, they're pretty close. These are the same, these have the same numbers, but one of them's positive, one of them's negative. So that one is a no. Now, if that question was yes, then it's the same line, and it would have been consistent and dependent. Okay, but it's not, so we're going to keep moving. Are they different equations that have the same slope? So these two, yes, my slopes are the same, but the whole equation itself, they're not the same. So this one is yes. Remember, when they have the same slope, those are parallel lines. If they are parallel lines, and I want to know what kind of system it is or what type of system, that is going to be inconsistent. Okay, so for this pair of equations, that is an inconsistent system. Now let's talk about number 4 for just a second. It wants to know, are they completely different equations? Well, no, they're not completely different because their slopes are the same. But if they had been different, so if yes, then these would intersect one time. And if they are intersecting lines, that is a consistent and independent system. All right, so that is it for section 3.1.